Just giving it a minute here. I'm not seeing anyone joining in for some reason. All right, for those coming in, we're just going to give it a minute for other people to get logged into the room here. There seems to be a few delays on Zoom this morning, so just going to give it another minute here. And I see Central York has joined us, so welcome. All right, we'll get started here. Good morning to everyone who's joining us live. I know a lot of you will also be viewing this on demand, so good morning, good afternoon, good evening to all of you that are joining us at a later date. I just want to go over a few things before I get to the good part of the program, but this program is all about exploration. It's a career exploration program, and what we're trying to do is hopefully get you some more information so you can make some better, more informed career decisions. Today's likely going to have one of three outcomes. This will either tell you that, yes, I'm on the right track and this is a career path that I'm already going that direction and I'm going to keep going that direction. It may leave you with a few more questions that you need to do a little bit more research, or it could potentially eliminate this as a career path for you. And I'm here to say all of those three things, those are all okay. It's perfectly fine. We want to be able to provide you some information to make a better decision to hopefully do something you're going to be really happy with for your career. Just a couple of things I wanted to go over. We're in high school. A lot of you are in high school. I'm not, but a lot of you are still in high school, and you're making these decisions. So wanted to just throw out a couple of statistics. The average college student is going to change their major 3 times. 80%, so that's almost all of students are going to change their major once. So they go to college with a plan, and then that plan changes 80% of the time, at least one time. College, of course, is expensive. It's coming up around $29,000 a year for tuition, room, and board. That's just in Pennsylvania for an in-state resident. A lot of times when you have to change your major, it delays your graduation. So that means you have to stay for another semester, another year. So that's more money spent, sometimes more debt. So what we want you to do is use these opportunities like you're doing now to explore what's out there and hopefully make the best, most informed decision possible. We're doing about 30 of these virtual programs this school year. Some have already taken place because we had some in the fall, and we've already done a few this spring semester. And there's going to be some from between now and April 29th. So I would recommend you check out our website. We have a lot of great hosts have stepped up to host these virtual programs, and certainly hope you check those out at some point. So I really should have said this to start, but thank you, York County School Technology. Really want to thank them for putting together today's program. Thank them for being here today. I did want to mention, if there are any questions, there is a Q&A box at the bottom. You can kind of see a sample of it there with the green circle going around it. Please use that Q&A. Feel free to ask questions at any time. You don't have to wait till a specific time in the program. Just you can throw them in there and I'll chime in and ask them as soon as possible. If you could, we're just going to leave the chat empty and not use that other than for us to post in any sort of resources or links or anything that might be helpful to you. So just use the Q&A if you have any questions. So just a reminder, if for some reason, if you have to change classrooms, you have to go somewhere else, you can't, you have to cut off the session, you don't get to see the whole thing, you can use that same link that got you here today. You can use that and just pick up the on-demand video at a later date, and you can finish watching the program. So with that, I'm going to stop my screen share, and I'm going to pass it over to Kevin for the program. The other Kevin, sorry.
Yeah, there's lots of Kevins here today. All right, hi, my name is Kevin Schussler. I work for York County School of Technology. I am their mechatronics instructor here. So the entire point of what we're going to talk about today is going to be what is mechatronics, how does that look in industry, and then how does that equate to what we're teaching here and possibly an educational route for you. So the first thing I want to start off with is what is mechatronics? So let me pull my screen up here. Share. All right. And it's taking a little bit. Apparently Zoom is going a little bit slow today. There it goes. Now it's sharing my screen. Or maybe not. It cut me off. All right, I'm gonna have to share from this view because it went up. There it went. It finally just popped up. And give me 2 more seconds here. It's a little technical difficulty with the screen sharing. 2. All right, we're going to share it this way. This PowerPoint has a lot of automation in it. Obviously, we're talking about mechatronics and automation. And so this PowerPoint has a lot of automation in it. And I guess Zoom doesn't really like that too much. So we're going to talk about it slide by slide. I first just want to define what mechatronics is. So mechatronics is basically the convergence of all the major industry disciplines. So you see things like mechanics and electronics, informatics. That might be a new word for some of you, but basically that's like information technologies, computer programming, robotic programming, things along that nature, and automation. And so mechanics and electricity and that information technology all comes together to form automation for us. Now that automation can be used in a whole bunch of different things. So we can use it in a factory to make motorcycles. Same kind of concept there, using it in a factory to make chocolate bars or bottles of water. We can take mechatronics and use it in a hospital to do what they call biomed, which is technology that helps people. And that actually goes into possible further careers in the power plant industry and things like that. So mechatronics is really wide, and it allows us to be able to kind of maneuver through the changing industry and technology as technology gets more and more in depth and more commingled with each other. One of the things that we do as a mechatronics technician, or just the way that I like to put it, is that we are jacks of all trades and masters of troubleshooting. A lot of people think that what I did in my professional career, I was like a magician. I would just show up and all of a sudden I'd be able to get whatever machine happened to be down at the time up and running, just by looking at it and, oh, we need to look at this pneumatic valve over here, or, oh, we need to look at this fuse that needs to be replaced, or, this wiring is not the right wiring, or the programming here is just not quite as efficient as it needs to be. And people would see that, my, coworkers and other people would see that as kind of like magic. And it's not. It's truly not. And I like to demystify that as much as possible in teaching this class here at York Tech. I try to tell people all the time, I'm just an average guy. You just need to know the right things. And once you start getting that troubleshooting and knowledge and the base root of how things work, you start to fill that role as that industrial magician where you can kind of just get things to work. So that's really kind of what mechatronics is. It's a commingling of a lot of things. We partner with a company called Siemens. Siemens likes to refer to it as the systems approach, which means that you're looking at individualized systems, but that are working together as a whole to make one complete process. All right, so I'm gonna just kind of wanted to show that there a little bit. So now I'm gonna rely on technology here again. I'm gonna try to go remote around my room here. So give me 2 seconds here to switch devices.
All right. Can you hear me now? All right. Seems like it's working good. All right. So I needed to switch devices because one of the main important things that I want to show everybody is what we can do with mechatronics. And I'm going to turn my camera around so you don't have to necessarily stare at my face the entire time, but you can see me walking around the room. So let's see. There we go. All right. So the one thing that I wanted to share, especially with everybody, is this poster that I have hanging in my room. We call this a career tree. And what the career tree does is it allows us to better illustrate what you can do with mechatronics. Because mechatronics isn't just one field, it's not just one job type, and it's not just one job description either. So out of the technology and the program that we teach here in York Tech, we develop our students with the skills to be able to land and have these jobs. And any school that teaches mechatronics is going to kind of do the same and similar, where you're going to have a multitude of career possibilities. What I'm going to focus on here first is entry-level jobs, and I'm hoping that you can see that. My screen's a little small because I'm on my phone here, but basically, some of the basic industrial jobs we would start out with would be a multi-craft technician, automation technician, an industrial maintenance technician, and a field service technician. Okay, so those all sound different because there's different words in them, but in all honesty, and even the line maintenance mechanic, all of those are actually the same job. They're working inside of a factory. You're working in an industrial environment on some type of production equipment. You are the frontline defense to faults and problems. You are the person that they rely on to keep production moving. Like the example I gave before about like the motorcycles and the chocolate bars, is that you're the person that is responsible to keep those motorcycles moving off the line. You're the person that is responsible for keeping those chocolate bars moving off the line. So when problems occur and things go down, you're the person that everybody's leaning on to understand what's wrong with that equipment to get it running. And then, so out of necessarily industrial or the factory setting, other jobs then, we were following down here along the line with electrical apprentice, green energy installer. I actually just met a gentleman just a couple of days ago. Absolutely loves his job, had a mechatronics background, and what he does is he goes and installs solar panels on people's roofs. Individuals and houses. He owns his own company, and he buys all the supplies. He prices it out. He puts it on the roofs. And again, mechatronics background. It's pretty awesome. Robotics technician. So these would be people that are actually working on industrial robots. Most of those are going to be like the robots that you would see if you go on YouTube and pull up videos of robots and automation, which I'm going to share with you here in just a moment. But just so you get a better idea. But you can go on there and you see all these robots moving automatically. And you could, out of a mechatronics background, you could become a robotics technician. Industrial systems installer is another job title. And that would be somebody that works for a company that installs industrial systems in warehouses or parking garages or things of that nature, and actually they're the ones that go out and do the work to install it, because a lot of those are integrated systems that have, again, multiple disciplines, and they need one person that is the point person that understands how all of those different pieces come together. Technical sales is an interesting, that's definitely not industrial in nature, but you'd be somebody that call the people up on the phone and say, hey, I need this part. You'd be the person answering the phone being like, okay, here's the specifications we have, and that kind of thing. Maintenance welder. So that would be somebody that goes along the lines and repairs and takes care of welding issues or metal issues. And then industrial machine operator. So again, those are all careers for what our program here, our mechatronics program, covers. You could really go into any one of those fields. Now, the cool thing, and this is the reason I like this, and I'm spending so much time on this career tree, when you take a look at this career tree, these jobs down here, the entry-level jobs, that's not the end. It actually is a road and a pathway to other places. And the next step in most mechatronics careers are these. And it's things like a mechatronics journeyman, an engineering technician, industrial controls technician, automation system designer, maintenance manager. And again, these are all like the next level. Most of these, all they require is just some experience, maybe a little bit more education, like you had to go back for certain specialty classes, some seminars, things along those lines. But it's a lot of this is just experience and time in the field. One of my favorite ones on here, and I have a friend that actually does this, is the nuclear plant operator. And that sounds, it sounds like Homer Simpson. I know it does, because that's what Homer Simpson's, technically on that show, that's what his job is. But it's actually a very serious job, as you can imagine. And in order to be able to do that job, you need to have the mechatronics background to know what you're doing. Facilities manager falls in line with that too. Aircraft mechanic. I actually have a student currently, a previous student, who is currently doing that. He's working on Apache helicopters, which is I think is awesome. And then machinist is in there. And again, all of these are great careers, but they are also not the end. Like mechatronics is so wide, and so there's just so much that you can do that the next level is actually all the way up here. Now, most of these are going to require some type of degree. Some of them are going to be like a master's. You could even go as far as a PhD, getting a doctorate. And yeah, so these are all the careers, and those are things like engineering level. So we got electromechanical engineer, industrial controls engineer, manufacturing engineer, a director of maintenance, electrical engineer, grain engineering engineer, and you see they're all kind of ending in engineer, and quality control manager and all of that. And so yeah, so the different mechatronics career paths are wide. They're long, and not ending. So that's something I really wanted to show you. Now, the next thing I'm going to try to do this is almost like a selfie here. But behind me, what you can see is my career board in my classroom. Okay, so these are all companies in the last 2 months, 3 months. It's been 3 months now. So 3 months ago, my board was empty. There was nothing on this board whatsoever. Okay, and then I started posting every job that came to me, and I have a lot of employers in the area that know what I teach, and they have desperate need for people of the mechatronics field. Okay, and so there are companies on here that I want to show you. So Apex Tool is over in East York, and it used to be Campbell Chain. They're now called Apex Tool. They are currently looking for somebody that is skilled in mechatronics. The U.S. government, that was this one here. The U.S. government up in New Cumberland, they were looking for somebody that was skilled. Amstead Rail is in Camp Hill. ES3, this is the video that I'm going to show you here in just a couple of minutes, but it's from ES3, and they have some very impressive automation up there for moving groceries around. And again, I'm going to share that with you in just a minute here or two. But you can see I've got 3 separate job descriptions here, and they are all for mechatronics related jobs. FedEx Ground is on here. FedEx Ground is up in Lewisberry. They also have a hub in Hagerstown. Frito-Lay is on here. Frito-Lay is over in West York. Magnesita is on here somewhere too. I know they're all here. If we get a little bit closer, you can see I've got stuff on here from Starbucks. Now, this is the roasting plant that's in Emmetsville. New Concept Technology, which is, New Concept is up there in the Emmetsville area as well. JLS is a machine builder. York Precision is also a machine builder. So you can see that, again, this is only 3 months. And I do this every year where I clear this board. I clear this board completely off. All right. And then it fills up almost immediately. So the jobs are there, and the jobs are definitely, available. I'm going to switch back over to my other computer because what I want to show you next is a video from my friends at ES3. And I do mean friends. I actually have spent a good bit of time there here recently learning about their automated systems and the things that they have. And I want to show you a video inside of their facility so you have an idea of the technology that I'm talking about. Okay, so let me switch devices here again. I'm going to try.
All right, no more terrible sounds. Everybody can hear me again? Awesome. All right, so let me share my screen one more time here. Okay. All right, got my screen shared. Get rid of that one. I'm going to pull this video up. And for some reason, it's muted. There we go. Okay, so the video that I'm going to show you here is from ES3. ES3 is at Strinestown. It is that gigantic warehouse that everybody can see from 83. So as you're going north on 83, you can see that warehouse. And I just wanted to show you what's inside that warehouse because it is pretty impressive.
Ideal logistics are imperative in the retail industry. SSI Schaefer demonstrates their award-winning Schaefer case picking system installed in the distribution center of ES3 in cooperation with C&S Wholesale Grocers, the US market leader in the wholesale grocery business. SSI Schaefer raised processes for ES3 to high-end technical standards. 15,000 different goods can now be picked and specifically sequenced for each store, fully automatic. Before the goods are stored in the warehouse, they have to go through a teach-in process where data is entered into specific software. A picture processing system collects all crucial information on the packages. The machine vision technology device allows more transparency of stock, expiration dates, range, and traceability of goods. Workers are now removing foil or other transportation safety measures from goods. Then they visually check the pallets and transfer them to a short conveying line. The pallet conveyors guide the goods to the depalletizing robots. The robots automatically depalletize the boxes layer by layer and put them on trays. This process is safe and gentle to the products. Even the slip sheets are automatically stripped and removed. Afterwards, the goods on the trays are transported across the conveying line to 6 transfer points. From here, they are moved to the Schaefer tray system, also known as STS. In this process, the equipped trays are administered by the IT system. Stockpiling of the goods is not done with the usual SRMs, but with lifting devices and vehicles, which conserve space. STS racking system has a height of almost 80 feet and offers storage space for 90,000 trays. 36 vehicles are constantly in motion and safely deliver goods to their destinations. The horizontal warehouse movements of the storage and retrieval machines are detached from the vertically operating lifts. This makes stockpiling and stock removal very dynamic and efficient. Case wheeler lifts perform removal of the stock. They move the trays to a separate packing level, up to 4,500 trays per hour. A vision camera determines the number of goods. Rollers push only the required cases onto a conveying line. The system sequences the goods according to the Schaefer pack pattern generator within seconds. It calculates the optimum packing pattern, which determines the sequence of stock removal from the tray storage. Now window conveyors transport the cases to the palletizing robots. Safe and efficient. When the goods reach the robots, they're already perfectly sorted. Goods get checked again. A total of 9 robots compile the cases for orders perfectly, arising by the ideal pattern, which has a calculated optimal volume and has been compiled according to product groups. This reduces the sorting effort in stores to a minimum. The system is designed for a throughput of up to 74 pallets per hour. The pallets rest on spindle lifts, which are slightly lowered after each packing level until the predetermined packing pattern is complete. Then the spindle lifts lower the packed pallets onto the goods out level. At the same time, they are automatically wrapped in foil by a stretcher. This increases stability. Finally, the goods are allocated via a conveying line in 2 buffer areas in the goods out section. From here, the perfectly packed pallets go on their way to the stores. There could not be a more efficient process. With this solution, SSI Schaefer has drastically increased the storage, picking, and supply quality for ES3. Even the Council of Supply Chain Management Professionals in the USA agrees. This solution at ES3 has been awarded with the Supply Chain Innovation Award 2011. Thus, SSI Schaefer sets new standards for intelligent intralogistics, even on the American continent.
Alrighty. So after seeing that video, I don't know if Kevin, if you had any questions and pop up along the way, because I'd like to take just a little bit of a break there and answer any questions from everything that I've talked about so far before I go on to our next segment.
I didn't see any questions coming in at this point. One of the things I love that you just touched on is I've gotten to tour that facility, and it's, I mean, the one thing that's, and I know this isn't necessarily mechatronics, but it's like if you've ever been in New York and you've seen the taxis and you're wondering how are they not constantly hitting each other and causing accidents, watching some of the pallets being driven around by humans and how quickly and efficiently and close they get. But I mean, they've gone, at least at the time I visited, they'd gone such a long stretch of time without any sort of accidents or anything. It's just, it's impressive how much is going through that facility. And I'm glad, I always love when programs like this kind of expose students to some of the things that are going on in this area. So that is an amazing facility. But yes, so many people drive by that and they're like, what is this huge building and what's happening in there? And that's glad you got to highlight that a little bit.
Right. No, I mean, I talk to people all the time, and you know, like I like to talk about ES3, and they're just like, well, that's just a warehouse, right? I'm like, oh no, wait, I gotta show you. It's not just a warehouse. There's so much.
That's not doing it justice. Very cool.
Okay, so the next thing I'm going to talk about and transition into is what we actually cover here as part of our course, our mechatronics course here for York County School of Technology. This is an adult education course, so this is a post-high school course. We do allow high school seniors to come in and take this course as well, as long as they're pretty much ready to graduate. But it is a college level post-secondary course that we run here. And in order to be able to do that, again, I like roaming around. I like talking with my hands and not so much sitting here at the desk. So I'm going to switch back over to my phone again, and it's going to allow me to actually show you the different areas and the different things that we actually teach here hands-on. So give me a second. I'm going to switch again and try not to hurt everybody's ears.
I'm just not fast enough with my fingers. All right, so hopefully I don't make you too seasick in giving you a tour of my room and what we do here. So with our mechatronics classroom, where we really start is with electricity. So when my students come in here, whether they just graduated high school, whether they're a high school senior, or they're an adult that is changing careers. And I tell people all the time, like I've literally taught anybody from 17 to 70 in my class. And I mean that sincerely. I had a gentleman who was 70 years old who sat in my class and he wanted to learn mechatronics and learn this, and he did, and he moved on and actually has a great career currently working for one of the local companies. But in the same, I have high school students that are 17, 18 years old that sit through my class, and the same thing kind of happens where they get to right out of the gate, right out of high school, go right into a meaningful career with what we've taught in here. So where I start, obviously we talk about safety first, and we do talk about OSHA, but then the main subject area that we cover is going to be electrical. And so you can see I have a store of parts here, and my students and I, we will go through these parts pretty much individually and discuss what they are, how they work, and how to connect them. And then that all transfers into being able to work on motor control systems. So motor control systems are these where you see, I got a magnetic starter here and some switches, and we will actually, control the movement of an electrical motor. And what I'm teaching in here when it comes to voltage, I only teach what is used in industry. And so we're looking at phased power in here. We teach, I started, of course, my students low, we learn Ohm's law and things like that. And we start with 24 volts, but we quickly move up through the voltage range. This set that's sitting here in front of us works at 208 volts. And then we'll come to stuff like this machine here, which works at 480 volts. Now, 208 and 480, they both are industrial standards. Like, this is what factories use. And so we will work through exercises to learn electrical systems, such as this, where this is just a simple motor control. My students this year built this. At the end of the year, I'm going to tear all this stuff apart. My class next year is going to have to build it all over again. And so I give them real hands-on experience from the ground up as to how to build these systems. One of the things that I pride myself on, again, is using things that we would use in industry. So in this this contactor in here it's not a simulation. This is an honest, real contactor that would be used for motor control. This, is a disconnect, which would be used again in a motor control scenario, much like this one. I've got a transformer in here. And again, that's a control transformer. Same thing that you would see in any industrial cabinet. And so again, that video that I showed you from ES3, all of that equipment in there that is running around, inside there's an electrical cabinet somewhere that has this type of equipment inside of it. And then again, we do get into some of the minutia of electrical as well. So like bending conduit, you can see, plenty of stores of conduit and things of that nature, running wire, and all of those things. So we cover electrical, pretty well and pretty through. And when we get to motors, I have to cover some mechanics. And this is where we go through, and we're looking at things like chain drives and gear drives. And you can see right here on this workbench, different types of sheaves and pulleys that we're going to use, and kind of work through and get to put together and see. Again, my students work with their hands all the time. So I might spend maybe an hour on theory in a class time, and then we're going to spend the next 4 hours actually working that theory out physically, so that way they're not just learning the theory of how things work, but they're actually getting to see it hands-on for themselves. Now, on the mechanical side, we also teach our students how to weld. And you can see I'm showing you the one welder I have just in here right now, but we actually have a welding lab here at the school where my students will go, and they have an expert welder come in and teach them, the basics of maintenance welding, which is very important. As well as on the mechanics side, we also teach machining, which, in the school itself, we have mills and lathes that our students will learn how to use those equipment. And in every maintenance shop that I've ever gone into, they typically have a mill in the corner, and it's just expected that the maintenance technicians know how to use that mill. Now, unfortunately, I don't have one here in my classroom. I just don't have the space in here, but that is part of the mechanics then that we teach in here as well. So all of this is pretty much industrial electricity that I've talked about so far. Then one of the areas, and again, I like walking around. I hope I'm not making you seasick on the camera. But yeah, I just like walking around. It makes it easier to talk. The next area that we end up covering are called PLCs. PLCs are programmable logic controllers. And if you want to think about that, these are the brains of every automated process. So every robot that you see, every conveyor that is part of an automated process is going to have a PLC behind it, controlling its movements and making it work. And so I take my students through the basics of programming so they understand how these actually work and operate. Just in case anybody really wanted to see that one up close, that one's ancient. And I like to show this one off because that's actually 1979 technology. And it's, people are like, well, wait, 1979, good grief. I mean, it's honestly older than I am. But the thing is, in factories, a lot of times, especially in smaller factories, because PLCs are so reliable, they're still using them. And I gave a tour of my classroom about a year ago, before the whole coronavirus really took in, and a guy saw that very PLC, and he's like, "Will you sell it to me?" I'm like, "Why?" He's like, "Because we have a machine, we have no spare. That's the PLC that's in the machine. It's been running since, again, 1979. We're now in 2020, and my machine, I'm worried that it's going to eventually fail." And I was like, "Well, no, I'm not. That's mine. I'm not. That belongs to the school. I'm not going to sell it to you." But it just kind of gives you an idea of how stable this technology is, and factories use it. And so when you learn this skill set, it's not one that's going to fade away quickly. When you learn how to program a PLC, it's going to be a very long-term kind of thing. Now, obviously, technology is changing continuously, and so there are extra things and new things. And I mean, you can see, that this particular PLC actually, does have like Ethernet capabilities on it, and a lot of my other ones do as well. And so there is an informatics portion of networking and all of that now comes into play with PLCs as well. So it's a pretty interesting and neat field to just look at all into itself. And I'd be remiss, let me turn this around so you can see my face for a second. I'd be remiss to tell you, so one of the neat things about a mechatronics education is you can find the things in it that you truly like, and you can focus on those. Because each one of these areas that we talk about, whether it's the industrial electricity that I talked about previously, or now PLCs, you can make an entire career out of doing one of those legs. So you could make an entire career out of industrial electricity. You could make an entire career out of working on PLCs. And there's actually quite a few people in the industry that do that very thing, where they just get really specialized in what they know. And then they just stay in that one area because it's what they truly enjoy. Okay. So one of the other areas that I teach in here as well is fluid power. Okay. And fluid power is both pneumatics, which is air, and hydraulics, which is oil. Okay. And you want to think, so we talked about PLCs are kind of like the brains of any operation. Fluid power is the muscle. Okay. And so we're going to use fluid power to help move products. We're going to use fluid power to muscle machines and move things around. And again, I pride myself in getting all the things that industry actually uses and putting these into your hands as an instructor. So that way, I mean, it kind of looks like a mess, but there's all kinds of actuators and regulators in there and valves that are real. Like, this is what you would actually see on an industrial machine, and I expose you to the real industrial components. Okay, so we do fluid power, and we get all the way through fluid power, and then probably the hardest class that I teach is one called circuit design. Now, circuit design, if the other classes that I taught were all about how and what things are, circuit design is why. And I do spend a good bit of time on why things are put together the way they are, because there is logical reason behind why we put, whether it's an electrical circuit and the types of fuses that we use, or it's a fluid power circuit and the types of hoses and things like that. There are real reasons why. And so, if I was to look into this disconnect right here, let me turn this around so you can see the disconnect. If I was to look into this disconnect right here, and I wanted to know what was downstream of this disconnect so that I could put these fuses in, because you notice there are no fuses in here. And I need to know, okay, well, what machine is downstream of this? Is it this taper right here? Okay, so this taper is what I'm going to plug into this disconnect. What kind of fuses do I need to use to be able to fuse it correctly? And that's the kind of thing that we work on with circuit design. And by the way, this machine is one of my pride and joys. So this machine was donated to us by a company called JLS. And if you look inside, you can see that it actually has a PLC, but it has and is built as an industrial machine. So it has all the parts, all the components. It has fluid power, motor control. It has all the parts that are required in order for it to be an industrial machine. My students get to work with this machine and get real life experience on working on automated systems, because it is an automated box taper. It's what it does. And they get to see it. So one of the classes that I ended up teaching, and it's the one we just finished, is troubleshooting. And they would, need to come to this machine. It would have a problem with the machine itself, and be able to go in and use all the knowledge that they learned, mechanical knowledge, the electrical knowledge, what they knew about circuits, the fluid power, and bring all of that together so that they could then troubleshoot and fix that machine. one of the biggest jobs that we as mechatronics technicians end up having is typically in a troubleshooting type role. And we will have to troubleshoot things under pressure. So if you can see on the board here, I actually give my students, when we're doing the final test here, they get 60 minutes, a total of 60 minutes to be able to repair a machine. And then they got to move on. And then I give them another machine, they get another 60 minutes. And the good news is, at least from my class this year, is most of my students were able to do it with they didn't even need 60 minutes. They got in looking at the machine, they understood all the different pieces and parts that were going on in there, and they saw the systems integration, worked it through, and solved the issue. One of the other parts of the program that we ended up doing and talking about for a good bit is robotics. And so this is my in-class robot that I have. It's actually from Rethink Robotics. It is a collaborative robot. And this is one that my students can play with and use, They can, work with it and use, as part of their capstone project, or just to learn off of. We also have access to, and they're just so big, so I don't keep them in my room, but we use industrial robots as well, which are the ABB 6. They have 6 axes on them, and they're real industrial robots. So what is the difference between an industrial robot and a collaborative robot? Well, collaborative robots are meant to work around people. This particular robot was designed to be sat in front of a machine in place of an operator. If you can think about that, they would put a different end effect on here, and they would have this robot press the start button on the machine. The machine would manufacture the part. All right. When it was done, the robot would open the door. It would take the part out, put a blank in, close the door, and then press start on the machine again, and it would run. And that's the whole point of a collaborative robot. So it doesn't have to have any guards, anything around it. Industrial robots are typically programmed for a specific task, and they are not meant to have people around. So they always put fences around them. So that video that I showed you of ES3 had those really large depalletizing robots in it. And they use those, again, they're all completely fenced off. There was really no human interaction with those robots, other than there's somebody standing on the side that every once in a while might have to press start, or the technician, the mechatronics technician, that has to go in and repair that bot. Okay. So we do spend a little bit of time there with robotics. The last thing that I want to show you is basically how our program ends out, because you can learn a lot of things, but if you can't apply them, it makes it that you just have a lot of knowledge, you don't know how to use it. So at the end of my program, we do something called a capstone project. Okay, and this capstone project, my students conceptualize, design, and build their own industrial machines. Now, these machines are prototypes, and what I'm looking for when we're actually building these machines is the systems that they put in place. And I'm gonna switch devices here again. Sorry, I keep going back and forth here, but it's, I think, the best way for me to show you everything that's going on here in our mechatronics lab. But I'm going to switch devices here again, because I want to show you some pictures of what some previous students built and kind of what they looked like, and just show them to you here a little bit.
All right, I'm back on again. My fingers just aren't as fast as they used to be, I guess. I don't know. Okay, so I'm going to share my screen here with you so that you can see some of my students' past capstone projects. The students that I have in my room now, I was trying not to get them in the video. I didn't want them to, have to worry about that at all. But that's actually what they are currently working on. They are in here working on their capstone projects now. Getting them ready. So let's get this shared. All right. So this is where we left off on this PowerPoint. There we go. So this is one of our capstone projects that a student put together. This was a simulation of a press, and he did a really good job on it. But again, just from the picture itself, you can see that it doesn't actually look like a hydraulic press so much. And that's okay as far as I'm concerned, because what I'm grading and what I'm looking at is the systems that they put in place. And one of the neat things with this is at the end of this, I actually invite employers to come in. And so employers that have hydraulic presses that are in their industry or they saw this and they immediately knew what he was doing. And they could tell, like, by the components and the parts and the pieces that he used, that he knew what he needed to know in order to be able to work on a hydraulic press. Some of my students are pretty inventive. So this particular student built what was to be an automated log splitter. He just had this like crazy idea of, you know, my family splits wood all season long, and it would be great if it was automated. And so he put into practice a completely automated log splitter, and it worked. Now, again, I was one of those, like you can see the log splitter down here on the bottom, just kind of barely. I didn't let him bring in like real logs in here and start splitting stuff in my classroom. I probably could have, but I was like, no, we're gonna hold off on that. But we saw all the systems, and you can see on the board here, like everything is open. You can see all the systems that he put into place in order to be able to do that. Obviously had to use hydraulics in order to be able to split a log. And so it's the combination of hydraulics and the electrical, and yeah, so PLC is in there too. This one was probably one of my favorites. So this machine was actually a cookie machine. They built cookies with this machine. And they have the little orange piece you see on the end there is actually an oven. And it's just a slow oven. And the cookies they ended up making were like a s'mores type cookie. I got to tell you, they were pretty good. But they worked it out. They had the entire machine working. And again, I tell my students it only has to be a prototype. I just need to see the systems in place. These two went beyond, above and beyond, and they actually built a working machine that made a product, which was it's just phenomenal. I thought it was completely phenomenal. So this machine was a machine that was put together to act as an automatic baler. So cardboard baler, and this student did kind of, you know, his take on what the cardboard baler was. And again, you can see they have buttons there and lights, and there is no physical cardboard baler anywhere, but they simulated the whole process with, you know, all the parts and everything that I have in my classroom. You know, they came up with an idea and concept themselves. They made the drawings, and then they were able to put together. And then when employers came around, they saw this and they're like, holy cow, like we've got, like, you know, we have one of those. And like almost every employer was like, I know what that is. I've seen that machine before. So this is my open house from 2019. This is another hydraulic press, another student who made a hydraulic press. This, by the way, is the student I mentioned earlier. He is now working on aircraft. He works on helicopters, and you know, he's absolutely loving his career. He emails me from time to time, just telling me about his successes and things. But he got his start here in mechatronics in this class. This student again made a simulator that kind of simulates I went too far. It simulated how a generating station works and gets its water to flow properly. And so he put all of those systems in place to get that. This gentleman actually went on to work. He impressed so many people with his machine. He actually went on to work for a company called General Dynamics, which that's somebody you should look up and research. It is one of the coolest companies to work for ever. They make all kinds of cool stuff for the military. This particular guy, again, this was somebody that just had an idea about something. He decided he wanted to try, and he built his machine. He made an automatic drill press. And so this would feed parts in and then drill them, feed and drill. And he made all the pneumatics work. He got the drill press to work automatically. He actually brought in one of those old desktop Craftsman drills that, like, a lot of people seem to have those old ones. And he completely automated the thing, which was it was just phenomenal to watch him to go through and use the knowledge that he gained from our course here to be able to do that. And then this Ben here, he took kind of the same concept there with the drill press and did the same thing with a bandsaw. Made it completely automated that it would feed pipe and cut to a certain length. And he actually had it down pretty good that you could program the size, it would feed it and then cut. Ethan, this was a sortation conveyor. He had something, again, he saw what ES3 was doing with some sortation that they had, kind of was inspired by that. And then he did the same thing, had a conveyor that sorted. And then the last one that I want to show you were these two gentlemen. They were inspired by a local company here in the area called Westphalia. Westphalia builds automated parking garages. And they're like, hey, we're mechatronics students. We should do that too. And so they actually did. What they ended up putting together was an automated vehicle storage facility. Now theirs just moved around Matchbox cars, but it was pretty neat. It did actually work. It was a neat little system to watch that they would actually put the little Matchbox cars away. The gentleman that I invited to come in from Westphalia came in and saw it, and they just absolutely loved their ideas and thoughts. And I think they talked with them for quite some time about just some of the ideas and some of the things that they came up with. So it was a good thing. So I keep kind of name dropping all these companies, and this is only just a small number of companies that I work with, but I work with and I talk with a lot of companies. I think it's super important for us as a school, for myself as a professional, to be well networked with a lot of companies. And so I network with myself with all our local companies here in the area that are using mechatronics every day. And so, I mean, you can see some names in here again, like Magnesita. They're actually a mine. Navaris makes auto parts. McCormick, they're down in Hunt Valley. They make spices. Everybody knows who McCormick is. If you like cinnamon, it comes from McCormick. Johnson Controls makes air conditioners. The RG group is a robotics group. They build machines, and same with KRB. They're a machine building group. JLS is the same. Capway Automation is in the baking industry. They build machines for the baking industry. And of course, Frito-Lay up there, they make delicious potato chips. Voith makes parts for dams. Apex makes chains. And so you see that they're in the York area in general, there is just a huge wide range of manufacturing that takes place. Mechatronics is the cornerstone to all of these manufacturers, to a lot of these builders, because the skill sets that we're teaching as far as mechatronics goes, this is what they need. This is what they need in order to be able to grow their business and, further succeed. So with that, I'm pretty much done. If anybody has any other questions, would love to take any questions. If Kevin has seen any pop up, otherwise I'm going to turn it over to Tiffany, and she's going to close us out.
Kevin, thanks for that. Sorry to hop in, but do you know anything regarding just anything specific about this industry? Because I mean, my knowledge of it is that this automation is not going away anytime soon, and there's so many of these jobs are in demand right now. And you mentioned Westphalia, and now there is a company where they're located in Germany and York, and they do all sorts of automated systems for, I know they're really big in the dairy industry and food processing, but then within the last, I'd say 10 years, they've got into these automated car retrieval systems for basically like automated parking garages. That was really cool to hear their name mentioned, because again, that there's another company that does amazing stuff all around the country and the world, and they're just right there off the Emmetsville exit in York, and it's just they're just kind of there, and no one realizes that they're doing all these cool things. But so yeah, I'm continue to be impressed by your network, and great job with that.
Thanks. Yeah, and it's only going to grow when it comes to automation. I mean, they're up by my house. Chewy just put in a facility up there, and it's supposed to be going to be a fully automated warehouse facility. So something along the lines of ES3 again, but again, they're moving dog food around, or pet food, I guess, pet supplies. And in this, it's just every business that starts in this area, they're going to be an automated business. Like that's just the way of things. That's how they're doing things. You know, and York is like this crown jewel. It's a really neat how, you know, between York and Hanover, we have so many companies in this area. We're actually South Central Pennsylvania that they're worldwide companies that do amazing things. And it's all going to be, it's all automated. It is automated. One of the best stories I can give on you know, how longevity and how things are just turning that way. So it has to do with Magnesita. Magnesita is a mine out in West York. They mine a material called dolomite, and they turn that dolomite into bricks. All right, that is, you know, part of it is just selling the dolomite. The other part is selling these bricks, and the bricks are used. Anyway, they're bricks. But they had a workforce in there to stack the bricks. All right, and they realized it was more cost effective for them and of course, because nobody likes to stack bricks. I mean, come on, what do you do for a living? I'm a brick stacker, you know. So they employed robots in there. They put robots in place and they made the entire system automated, which in the end benefited the company. So now they're able to do their process more efficiently, faster, and get the product out the door to their customers more efficiently. So and that's just one of those changes. Like you see that more and more industry, doesn't matter what industry it's in, they're looking for a more effective, more efficient way to go. Robotics and automation is that way.
Great. Sorry, Tiffany, go ahead. I wanted to interrupt.
Oh, no, you're good. You're good. Kevin, can you share my screen? Schussler? Maybe. You're good. He has it. Sorry.
Sorry. I was the only Kevin growing up in my high school, so I heard that. I was like, wait, what? Like,
You're like, I have stuff? No. Thank you. Thank you. All right, Mr. Schussler, thank you so much for sharing all the wonderful information about mechatronics. I know every time I hear you speak, I learn a whole lot of new stuff too that I never knew. But in addition to mechatronics, I just briefly wanted to show you the different programs that we do offer here at the Adult and Continuing Education Center at YCST. Our full-term programs, including mechatronics, will be starting on August 26th this year. We enroll approximately 20 to 25 students. So we keep our class sizes small. This allows for a lot of one-on-one interaction with your instructor. Another thing that is absolutely amazing, everything that Kevin Schussler just spoke about in mechatronics only takes you 9 months to learn. All of our programs are completed in a year or less. So in 9 short months, he went over a lot of stuff, and I can't imagine learning all of that 9 months, 900 hours. But he'll get you through it, and you will learn. So in less than a year, you're out there, you're working with those amazing companies that he spoke about. You're making good money, and hopefully you're in a career that you love. So again, there are just a list of the other programs that we offer. If you'd like to learn more, though, about mechatronics or any of the programs that are listed, next slide, please. Please feel free to reach out to us. You can always go to educationthatpays.com. It is a landing page right now. We are currently working on our brand new website, which we are super excited about. But if you visit educationthatpays.com, you can select on whatever major you're interested in learning more about. Fill out your basic information. I will receive an email and I will follow up with you to provide you that information that you're looking for. Also, you can always follow us on Facebook and Instagram. And then most importantly, we have an open house coming up on Wednesday, April 7th from 5 to 7 p.m. This is held in person. So we are super excited. We're inviting you out to join us. You would just want to enter the school parking lot from the South Queen Street entrance. So that's the very front of the school. Park, walk towards the big courtyard area. In the front there, you'll be able to come in. But what's most important, not only are you going to be able to tour the school, learn about financial aid, but you actually get to go to these labs and into these classrooms and into these shop areas, and your instructors will be there. So you can have these one-on-one conversations. You can meet Mr. Schussler in person, actually see everything that he was talking about today on his presentation, and really just get a feel for what we have to offer. So we would love for you to come join us. Again, that's Wednesday, April 7th from 5 to 7 p.m. If you'd like to learn anything or have any other questions, please feel free to reach out to me directly at tgraham.edu I'm sorry, tgraham@ytech.edu. And that's just TGRAHAM@ytech. All right, we thank you so much for your time today. Have a great day.
Sorry about that. I was actually just trying to quick copy your email address. I'm just going to throw it here in the chat, just because then anyone who tunes in later then will be able to see that. So, well, hey, thank you so much for your time. I appreciate it. Tiffany, like you said, I'll echo that I always learn something new. Really, in all these programs, I always think like, oh, I've heard this, I get this, and I always pick up something new along the way. So, very cool stuff. Thank you so much for taking time out of your day to do this, and appreciate it. Have a good
Thank
rest
you
of
for
your day.
having us.
Bye, everyone.
Bye-bye.